Hi, good morning. Thank you for joining me in the hangover slot. I really didn't think there would be so many people here, so woo! We're off to a flying start. My name's Lorna. I am a developer advocate for IBM, and I can discharge that duty very quickly by saying, did you know IBM has a cloud? You can run your apps there with lots of lovely open source databases. Okay, good. Now I can just talk about the technology. I'm going to talk to you today about CouchDB. It's an awesome document database. I'm going to talk a bit about document databases. I'm going to show you around CouchDB. Not too much, just to give you an idea of how the moving parts work, because you'll obviously just actually look up the details when you do this for yourself. I'm also going to talk about something called PouchDB. This talk is full of good examples of why geeks should not be allowed to name things. And CouchDB and PouchDB are a really good example. PouchDB is a JavaScript implementation that knows how to talk to CouchDB. And as a result, then you can have it in your browser and you can create apps that survive when the network goes offline. So we'll talk a little bit about that and I have a demo for you later on. So let's begin with CouchDB. It's a NoSQL database. And what does that even mean? Well, the answer is it can mean all kinds of things. It's a bit of an umbrella term. We've got graph databases in here. We've got key value stores. The search stuff, Elasticsearch and friends, also belong in this space. So today we are here in the middle somewhere. It's a document database. So CouchDB is a thing that is like these are the things. So RethinkDB might be quite similar. If you've used MongoDB, lots of same ideas there. So it's a database which is works on documents. So it's schemaless. You don't define the table or tables, give column names, and then each thing has to be a row that's the correct shape for the table. Document databases don't have that. This is supposed to be a diagram of 3 records that are similar but different. Not sure how well that works. So the idea is that you can just put in the data that you need. And when you are coming from a relational database backend and somebody says to you, it's schemaless, you can have your data in any structure you want, and you think, really? That sounds like chaos. So let me tell you a secret about schemaless databases. Strangely enough, if you look at multiple records in a schemaless database, you'll find that they more or less follow the same schema. Really, they look a lot like each other because you are going to read and write these records with the same piece of code. The schemaless stuff is brilliant for situations where the records can be similar but different from one another. So great examples are if you have a database of products, then some products come in colors. Some of them have height or width. Maybe they're a shoe size. They might be measured in amps or horsepower. But each one is different, right? So you end up with all these columns that are almost all empty. If you've used Magento, they try to solve this with the EAV anti-pattern. It's actually probably the best of a series of bad choices for solving this problem because it just doesn't fit well in relational databases. The other place that I've seen document databases used really well is for like content management. So you have a series of blocks on the page, and maybe there's a title and an image and a paragraph, and there's a widget here, some kind of form. And you can have code that knows how to display lots of different types of item, but those need slightly different fields associated with them. And the document databases make all of that super easy. So let's talk about CouchDB specifically. As an advocate, I have CouchDB, MongoDB, and RethinkDB all in my portfolio. So I get to play with all of those. And I don't like to have favorites, but right now, CouchDB is definitely my favorite. And maybe it's just because I'm working with it loads at the moment, and you'll meet me next year and I'll be like, no, Rethink is totally the way. But today, CouchDB is my favorite child. It's got an acronym, helpfully. This is a PHP conference, so hopefully you don't think that's weird. It has an acronym, and it stands for Cluster of Unreliable Commodity Hardware. So CouchDB is actually not a brand new database. It's been around for a while, And it comes from the idea that you should be able to get like a bunch of second-hand physical servers and stick them in data centers places, and sometimes hard drives will fail because you bought these and they don't match each other, right? And this database is going to survive all of that. It is designed for sometimes things go wrong on the internet, which, yeah, is part of my reality. Things go wrong on my internet. Other reasons that I think CouchDB is a really good fit, especially for web developers. It has an HTTP API. So you talk to CouchDB by making web requests. If you've ever worked with a RESTful API, you already know everything you need to know about talking to Couch. You do not need extensions. You do not need drivers. You do not need libraries. You do not need to wait for some provider to ship the library for your programming language of choice, and you won't get bitten when they upgrade in a backwards incompatible manner. Not that there's anybody in the community who's done that recently. It speaks JSON data format. So whether you like it or not, JSON is very common. And what is likely is that you probably have tools for dealing with JSON, or at least there are good tools for dealing with JSON. So it's a data format that's easy to read and write. It's not very human-friendly, but it's very machine-friendly, and it's not hard for us to work with. You probably all write SQL. I do. But for someone coming to web development for the first time, SQL is a new discipline that they have to learn in addition to the programming languages that they're learning. CouchDB doesn't need this. You write queries and views. You can do ad hoc querying with something called Mango, which is supposed to be like the Mongo query language, and geeks should not name things. But also, the views that you'll create for getting really well-optimized data back from your database will be written in JavaScript. You just write some MapReduce functions. Some of you are familiar with that. Some of you are not. Going to do you a recap anyway. CouchDB, like I say, isn't brand new, but it's been out. It's had a new release about 9 months ago, which has a bunch of scaling and sharding stuff inside it. So if you want to run it at enormous scale, you get that out of the box now, which is nice. So let's talk about the HTTP API. And we can reach this quite easily by just making a curl request. So I'm making a curl request here to localhost, and it just chats back and says, yes, I am CouchDB, tells me what version it is. It's an open source project, and it's an Apache Foundation project, so that's the version that I'm running here. To get a list of databases, you just hit this special endpoint, _all_DBs, and when I ran this on my local machine, it was empty. It's not very exciting. So we can fix it by creating a database. Remember I said it was RESTful? So we're going to use put. And you just put to the place you want the database to exist. You get back the OK. If you had the headers as well, if you had the headers as well, it wouldn't fit on the slide. But if you had the headers as well, you'd see a 201 created here. When I list the databases again, they come back. You can see it's in the list. We've created a database. I'm showing you examples with curl. If you love curl, then you need to get to know this tool, JQ. It's a thing that's going to handle JSON for you. So you're going to get a response back from curl, which is JSON formatted. By default, curl will show you this just on the terminal, all on one line with escape slashes everywhere. Pipe it to JQ, and you'll get it syntax highlighted, nicely laid out, pretty printed, colors, everything. So if you're using curl, get to know JQ, totally worth it. If you don't love curl, I kind of respect that. I've got a couple of other tools that you might find useful. The first two are still console-based tools, so you're still going to use them from the command line. The first one is HTTP console. It's just an npm install, and then you can use it from the command line. I quite enjoy this, and you'll see some examples of it in use. I've got to mention HTTP, which is supposed to be a more humane version of curl. So by default, it gives you back a nicer output, and the arguments are slightly less arcane. I've never bonded with HTTP because my fingers already know how to type the curl commands. And it's like I've typed it in curl, And then it's like, oh, there's that other thing that I should have read the docs for, but never mind. So I've never really bonded with it because I learned curl first, but I think it's a really good tool and something that if you don't already know curl, you might like. If you would prefer to have your HTTP requests and responses served not on the command line, I respect that as well. So have a look at Postman. It's a really nice GUI tool. At one time, it was a Chrome plugin. Now it's a cross-platform standalone app. Postman's nice because it gives you fields for what's the URL, what's the port, what's the verb, what data would you like to send, what format would you like that, and it'll show you the responses nicely formatted. Keeps a history of what you've sent so you can pick out the sidebar to send the request again or change it a little bit or experiment. So it's a very approachable way of, these tools are for all sorts of APIs. And CouchDB just happens to be a really cracking HTTP API. So let's have a look at the HTTP console tool in action. To set it up, you just say, you install it with NPM, so it's with a global flag with the -G, and it becomes a command at your command line. So you're going to run HTTP console, localhost 5984 is the default location for CouchDB. Seems like a random number, but if you type it on the number pad, it's like a little pattern. And the thing that I like about this is once you're inside the HTTP console prompt, you don't have to keep typing the URL or working around the URL. It just remembers it. And I can add the /shopping because I'm going to do operations on that database. It's called shopping because my demo is a shopping list. It's a list of items. We're going to add some items and go offline and keep adding items, so shopping. I can also, the third command here is just setting the JSON header. So whenever I'm making a request that has body from HTTP console, the content types and entity header, it'll send this. So CouchDB needs you to send the content type correctly with the body, so that's how that works. Now I don't have to remember it's there, which is great. So to create an item, you've already seen create, we use put. And I use put because I'm defining the ID. It's going to be called hat, /hat. You don't have to do it this way. You can create with post. Don't define the ID, and CouchDB will give you an ID for your, just like an auto increment, except it's more like a UUID. If you do that, it doesn't fit on your slides. So I'm calling it hat, so that my examples work. You can go either way with that. HTTP console then prompts me for the body of my request, and I supply some data to go with it. And I get this 201 created. So we've created a record. We did a put request. I know it's early, but I'm pretty sure you're still keeping up. If I want to update something, I do put again, right? You know how REST works. And I send some data. But this has failed. It's come back with a 409 conflict. And that is because to update in CouchDB, you must supply the revision. When I created the record, it came back with an ID and with a revision. And this is how CouchDB works to not lose your data ever for any reason. So because the updates are not atomic, right? You get it, you change it, you put it. That's the problem with RESTful endpoints. It uses the version. So you have to say which version you think you're updating, and then you're allowed to update it. So if the database is on version 3, and I get the data and you get the data, and then you make a change and you push the update, I make a change, I try to push the update, I can't update version 3 because it's now on version 4. So I don't overwrite your changes. The protection is there for that. I'll need to get it and change it again and put it back. It'll never try to merge your data because how would that work? So instead, we supply the revision that came back when we first created it, and then we can successfully update. Have a look at the status code on this response. 201 created. We created a whole new document with a new revision, and the old one is still there. So that's how it works in terms of we actually create a new document with a new version number. CouchDB is smart about it'll just come and tidy these up. Your database does not get, it sounds like your database should get enormous very quickly. It really doesn't. There are ways that you can make it enormous. If you write and delete records a lot, it struggles to keep up with compacting on that. So if you're doing large numbers of writes that then get deleted, that's not an optimal use case for CouchDB. For most use cases, it's brilliant. So if anyone else is tired of looking at the terminal, that's fair enough. Let's talk about Photon. It's CouchDB, and it used to have a JavaScript web interface called Futon to go with Couch, and then we made another one, and it's called Photon because geeks are naming things. Okay, good. It looks like this. You just go in, get a list of the databases that you have, create new databases. This is your PHP MyAdmin, if you like. So everything you've seen so far, you can easily do through this web interface, and it works if you connect to servers elsewhere and stuff. So it's nice. It's kind of angry red. IBM has a slightly rebranded CouchDB, and we call it Cloudant. Ours is like soothing blue. And there's also a plugin for the PouchDB, the local JavaScript version, and theirs is green. So you sort of see this in different ways. The red is quite striking, but it's right in line with all the open source branding. So. And you can come in here and have a look at all the documents, fetch them out. You can see there's the hat that we created and then updated, and it's all in the database. And you can see it here. So I have it running. I do not have a shopping database. We are going to need it. So awesome, it's here. So you can just create a new database, start adding things to it, be like, yeah, I need a document. And it's all just here in the web interface if you prefer to work this way. And I think when you're just poking around and creating things for the first time, at least being able to come and see it like this and see what you just did with your magic command line incantation, or if you're using a library in your programming language, I really like this interface and I come here a lot. Something that I really value about this tool. So far, I've shown you around CouchDB. It's a document database. It's awesome. It's very web-friendly. It's very performant. It's very scalable. It's very approachable. It's got this Photon web interface. And I feel like we could stop there. There are other document databases around, and I've covered everything that they do. And it's, by itself, pretty cool. You can guess I'm not going to stop there because it's 10:03. OK, so let's talk about some of the stuff that is different about CouchDB. CouchDB has a changes feed. You can get a feed either by polling or by opening a socket and having those changes arrive. You can get notification of every time there is a change on your database. Can you think of a use case for that? Some sort of event notifier stuff, knowing when anything's changed, and you can put the reaction, the audit trail, the notification, whatever it is, somewhere else. Like, I could write more on this slide, but I just feel like it's a feature, and as developers, you're going to get it. And the reason that this is here is because CouchDB's superpower is replication. Some of the other databases have stuff like this. RethinkDB has the ability to subscribe to changes in views, which is incredible. But CouchDB has this changes thing, so you just get it and filter it. And it's here because we use it for replication. This is how CouchDB's replication works. But the changes endpoint is available to you to implement whatever else you want, because it's there. Why shouldn't you have it? Let's talk about replication. And you're sort of thinking master-slave replication in MySQL, and it's a little bit different. CouchDB is a distributed database. All the nodes are the same. Nobody's in charge. We can set up replication that's ongoing. So these two databases, or these 200 databases, or however big you need it to be, stay in sync with each other. A change on one will replicate to others. Changes in both places will replicate. If the network connection gets interrupted, they'll replicate it later, even if there are changes on both sides of the net split. You can do it as a one-off. I use the one-off a lot to grab a database that we're working on locally so that I can just hack about with it and not annoy anybody with my changes. Try some stuff, work on some views locally, and then send it back. And you can replicate by pulling down to the server that you're working on or pushing up to a different one. You can do both, so it can sync in both directions. You can set that up to keep on replicating, so that's what uses the changes feed, or you can do it as a one-off. Other things that are not CouchDB can also join in this conversation. You're going to see PouchDB, it's the JavaScript implementation. In the PHP space, we also have Drupal uses this. If you use Drupal, and I'm going to say it was in 8.2, the workspace staging feature, where you can put all your content together and then replicate it to the live site without overwriting what's on the live site, that uses the CouchDB replication protocol. You can replicate from Drupal to CouchDB and from CouchDB to Drupal or other Drupal, but the Drupals can also speak CouchDB replication protocol to each other. And that's how they deploy their content changes from one place to another. It's by implementing this protocol. So CouchDB will talk to anything that knows how to talk the open replication protocol, which is really nice. And it's interesting to see things like the workspace staging coming into play. I made the grand claim that you could edit records and then replicate in both directions when both have changed. How would that work? Well, it's a conflict. Unlike a Git conflict, where Git will stop dead until it gets some adult intervention and some help to move on, CouchDB does exactly the opposite. It looks at two different versions of the same record and makes a decision about which of those is the right version. So if you've got two servers and the connection between them is broken, let's say we drill through the transatlantic cable and I connect to the databases on both sides and change the same record, those are in conflict, right? There are changes on both. If the records have been changed and ended up looking the same, CouchDB knows that now. It didn't in old versions, it does now, so it'll be smart about that. If you've got different changes on them both, it will make a decision about which one you need. And it's what's called a deterministic algorithm, which means it'll always choose the same winner. Given the same two documents, it'll always choose the same winner. So the replication kind of just sorts itself out quite quickly. What if you actually didn't want to lose that other document that we just overwrote? It will never try to merge the data, because how would that ever make sense? It will choose a whole record as the winner. The loser you can find by looking at when you fetch the document, you can ask for this conflicts equals true, and it will show you if there are any loser documents that have been overwritten by replication. And you can fetch these documents. So if you've used WordPress and sometimes you go back to it and it says, there's another version of this, there's a newer version of this post, would you like to see it? You can do that sort of feature, you can implement that kind of thing very easily because we have both documents available to you. So you can just get the other one and be like, do you need one of these? In practice, I don't see this implemented very often. For the most part, users know if they edit in two places, they're only going to get one of them. CouchDB tends to choose the newest change or the most change. So if you've done loads of work on one, you'll normally get that one. And that works pretty well. There's an element here about data design and about structuring things so that you're not always updating the same record. You're not updating loads of things inside a document, because at the document level, you would have more smaller documents if they get written and updated a lot, so that you have fewer conflicts. So you can fetch that losing one by just specifying the revision when you fetch the resource, and then you can get that back and see this is the old version that we had. They're not there forever. Like I say, it does compact, but when you've just done the conflict, it is available to you, so you can follow through. Crucially, it doesn't need your input. So even like a huge replication, I hear funny stories about people booting up old servers and realizing that CouchDB is syncing. And you're like, no, this was a test database 3 years ago, and it will successfully sync. Quietly, without any intervention, it will always work through it. Oh, cool. Let's talk about Mango. So Mango is intended to be a Mongo-like query language. This is a new feature. I would say it's not all the way there. I'm not sure how much its creators used the Mongo query language either. And it doesn't yet do aggregation, or not much aggregation. For this, I'm using a sample products database that I've taken from IBM's Open Data Collection, because we've got a database with a hat in it. That doesn't make for all that interesting queries. So I've got some products database. It's here if you want to have a play. You can just replicate this down to a local CouchDB and try everything that you're seeing here. So the way that Mango works, Mango's a bit more SQL-like in the sense that you specify a list of fields, you specify a list of criteria, you say how you'd like things sorted, there's some like limit stuff so you can do pagination. So the ideas feel kind of similar. And we use this for more ad hoc querying. It works better with indexes, which you'll see in a minute, but it doesn't really, you don't necessarily have to plan ahead, which we usually do for CouchDB and views, which we'll do next. So you can do it here in Photon. Click on, I would like to query the database, and it will give you this. You can't possibly read that, so we will instead look at it in this format. So you can write a query like this. So my selector is my criteria. It's my where clause. Please note that the fields are case sensitive. This took me a while to get working because I didn't think it should be. So all the field names are case sensitive. And here I'm just saying, show me all the products added in the year 2012. So I'm using that $equals. You get greater than, less than. You can put some functionality in here. There's a list of fields and limit 5, because that's how much fits on my slide. You can use the Photon interface that I just showed you, or you can post this to an endpoint. Every database has this _find endpoint, and you make a post request to the endpoint, and you get results back. So they come back and they look something like this. Here's the post command. So curl, it's a post request. I'm sending JSON. I'm hitting the CouchDB URL. The database is called products, and it's the find endpoint. The code that you saw on this previous slide is in a file called mango.json. I won't say that I never type JSON on the command line, but it's not something I especially enjoy. So I find it better to dump it into a file, and then you can supply the data with an @ file name like --data like this for curl. And it comes back, first of all, it comes back and says, you have no index. It kind of says you are an idiot. No, the words say no matching index. And then you get some data back. And this is just saying I had to do the equivalent of a full table scan, right? So like, I'll run your query, but you probably want to fix this. Creating indexes is fairly straightforward. Because you just say what you want it to be an index on. In this case, my criteria is year, so that's all I need. And I've called it year so that I know what's in it. And you post that to the index endpoint. When you're working with, and you post it like this, when you're working with Mango queries and posting to _find, replace the _find with _explain to have CouchDB tell you, these are the indexes I think would be useful. This is the one that I picked. It's normally correct, but when you're debugging, it's really useful to be able to get that explain plan. OK, the other way that we get data out of CouchDB, and this is a more long-standing approach, so if you've worked with CouchDB before, you'll have seen this, is to use a view. Now, the views are written in JavaScript, which, again, I think is quite web-friendly. And it uses MapReduce, which I'm going to talk about more in a minute. MapReduce is just some smart, intelligent people thought about a good way to do scalable retrieval and aggregation of data from databases. And they wrote down how to do it, and now we do it like that. It's a two-step process, and the first step we do and we store. So the views are very efficient. You're not recalculating anything every time you hit it if you're just filtering. You can then use the filtered output to do some aggregation. So anything where you would need a group by in SQL, if you're doing average or sum or count. We have some geospatial features which doesn't fit in today's talk, but it's quite fun, and you can ask me about it. So here is your 2-minute MapReduce refresher course. It's a two-step thing. We start with map. So what we do in the map step is we look at each of the documents in our database, and we decide whether anything in this document is of interest to the view that we're trying to create, so to the question that we're trying to answer from our database. And we may or may not emit none, one, or many keys and values, given what's in the document as ingredients to the view. It scales brilliantly because each time you look at a document, it doesn't rely on anything else that went before or comes after. So this can just scale out to as much compute power as you have available. This is the key to scalable systems. Every part of this operation is independent, and we can do it one after another locally on a single processor, or we can do it in the cloud with hundreds of cores. And it all just works the same way. It will use as much resource as you make available to it. So that's the map step. You only need map if you're going to filter. So if we want products from 2012, we're asking a question of the products database where the answer is still a list of products, but probably not all of them. So we're only filtering, and that means that we only need the map step. We store the output. So we go through the documents, we generate this view, it's a one-time operation, then we store it. Every key and value in this view knows which document it came from. So if the document gets deleted, we can remove it from the view. If the document gets updated, we can reassess it and update the view without updating all of the values. This also means that we don't need to put the document as a value in the view, because we can always get the whole document. So you'll see that I don't really have values in my views, and this is because the keys know which document they came from, so I can always get those documents back. Here's an example view. I'm about to put it in a diagram. It's going to get very small. So look at the JSON while you can see it. I've got a product. It's got a name. It's got an array of departments, and this is something I like about document databases. You can have nested values. It's got a field to say whether it's in stock, and it's got a date added. So that's the sort of structure we're looking at for our document in this example. So I take that document, and I run it through this function. This is how you write a map function in CouchDB. It's a function. It accepts a document. And if you want to emit a key, you use this function emit with key and value, right? It's a PHP conference. I'm showing you some JavaScript. It's the hangover slot. Everybody's still coping. The function takes a document and you use the document to call emit with key and value. Good. I knew this was going to be fine, technical conference. So we take the document and we emit the name. I haven't emitted a value because I probably just want the document. The only time that you emit things here is if your document is huge and you know you only want a few fields, then that keeps it nice and small. Don't store your document here because it makes your view very big and you can get the whole thing back later. So for every record, we will emit a key. So this is supposed to be a picture of emitting one value. If we only want the products that are in stock, we can just assess the document and say, is this product in stock? And if it is, emit the value, and if it isn't, then don't. So with this example, we might or might not emit a value in the map step for each document. If we want to do a view where we count how many products are in each category, some products are in more than one category, so we need to, I've got department here, which department they belong to. We need to emit a value so that it can be counted for each of the departments that the product is in. So in this case, we emit multiple keys. And that's also quite normal. It allows us to answer that sort of question. This is reduce. We take those values that we emitted, and we line up a series of buckets. And we put all of the emitted keys and values where the keys match into the same bucket. So I put all of this department in this bucket and all of this department in this bucket, and we line it all up. So I've got a series of buckets all with matching keys, and then we run the reduce step. And the way that works is you take an individual bucket and you do whatever the operation is. It's normally count or sum. You can you can write your own reduce functions in JavaScript for CouchDB. Haven't seen it used all that often. Most of the questions we answer are things like how many, how much, what's the average. Because once we've filed everything into the right buckets, actually processing the buckets is each of those jobs is independent, again, it scales really well. There are reasons why this is used on very big data, and these are the reasons, that we do the map step, we sort out the keys, we bucket them together, and then we run the reduce. And those individual reduce jobs are independent. These could run on different servers or whatever. In this case, I've got 3 in this bucket, 5 in this bucket. And the reduce function is going to be count, and the output is just a value. So you use the reduce step when you are aggregating, when you want a smaller answer, how many in the department, than give me all the products in this department. That's filtering. Aggregation is when you would use anything where you would use group by. I've got an example. Here's one I made earlier. In fact, I'll just show you here. So, let me just get my crib sheet so that I get this approximately correct. So I've got some views already set up. This is the year view code. This is the year view. I'm not going to fetch all of it because it's quite long, but I can use it to get, you can use a view to answer a bunch of different questions. So if I turn off the reduce on the view and ask it to include some documents, that is not how you spell docs. I will admit to having been out last night. Okay, good. And let's put a limit on this, because otherwise you'll just be watching it spooling, which is not particularly found. Missing named view. Why? I just ran this a second ago. That exists. Oh, I just can't type. That's fine. Let's not worry too much about that. Include docs is invalid for reduce. Reduce equals false. There we go. So you can get data back, and here it comes back. You can just use it. So this is the kind of thing you would use from your application. You can also start to filter things. So if I only wanted those 2012 type records, then I can start adding key filters and say, well, I'm emitting, try to see if I can spot this in this. I'm emitting a key for 2012. My slides are bigger than me. So you have the key, and then because I've done include doc, I've got the whole document as well. So that I can filter it and only get ones with key of 2012. If I want to know how many records there are per year, I can use the same view again, but use the reduce which was associated with it, which is actually set up to be count. So counting how many records there are in each year. If you run this by itself, it just counts how many records there are. But if I turn on the grouping and say, use the keys to group these, then you get the answer of how many there are in each year. So it uses the key and then applies the reduce to each matching key. I also have up here a quarter field, which has the year and the quarter, so which period in the year it was in. And I can use that in my view. So my view is just, let's dig it out of Photon so that you can see it. So on the products, here's the views. It's year quarter. If we look at year quarter, and I try and make this bigger, let me know when you can read it. Oh no. So all this does, the code's here in the map function, all this does is passes out the string a little bit and uses the year and then the quarter as a composite key. So now I can choose how much of that key I care about when I hit this view. So if I go here and use this view, which is called year quarter, then I'll get more or less the same thing. It just shows me how many records there are. And then I can turn on the grouping, which is what I did before, to say, yeah, I'd like you to use the keys when you run this view. And it shows me 2012, the keys, and then 2013. This is just the date interval that I have data from. If I'm only interested in the year, if I want to answer that same question I answered before, then I can use group level 1 to say only use the first part, and it answers the year question again. So you can set up views which use multiple keys and then choose how much you want to take of it. For example, it's quite common to see keys which are composite year, month, day, hour, minute, second. How much do you care? Over a day, maybe you want it by the minute. Over a year, probably by the month. And that's all from one existing calculated map view. It's very cute. Okay, so frustratingly, they've already given me the 5-minute warning, but I am desperate to show you this thing. So CouchDB's replication, I kind of mentioned that it was amazing, but it's enabling a whole new part of the web. PouchDB is a CouchDB-compatible local JavaScript library. You can run it in a Node backend, but I'm going to show you in a browser, which is where it's mostly used. And it'll use either the IndexedDB or local storage stuff. Don't ask me front-end questions. But it's amazing, and it talks to my CouchDB. If you're using it, then you want this that I've tiny URL'd. It's a plugin that gives you a tab in Chrome, which has that photon thing in, so you can see what's in the local database. And what's going to happen here is we're going to write a client-side application that uses a local database. So as a user, this is a really slick experience, right? Because it's really fast. You're using your browser. The web app is just writing to its local database. It's fast, 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 fast. Anytime you're connected, there's a background sync out to the server. We'll need to preload some stuff or occasionally fetch things from the real world, yes. But once you're working with it, your focus is here, and the app is very much focused on the user. And then we just set up this background sync. And here I've got a local PouchDB, this one's PouchDB, syncing to, I don't know, imagine some CouchDB clusters of some kind. You can sync out to more or less anywhere. I am not a front-end developer. I'm really not. So I started trying to put this together on the basis that my team would be more likely to help me if I had something that I'd tried. And then an hour later, it was working. So it's really a very straightforward technology. All I need to do is include the PouchDB in my index.html, and I've also included shopping.js, which is where all my code is. It's all on GitHub. You can go here and see it working. Here is the replication part. Here is the background sync. So we create a database. It's just a new PouchDB. That's the local one in my browser. I also create RemoteDB. That's the CouchDB somewhere else. For the purposes of conference demo, the CouchDB is running on my laptop, because that way it doesn't matter if the internet's not working, but the setup would be the same. All I've done here is set up the sync, which is two-way replication between PouchDB and CouchDB. When there's a change in either place, I've written some code that asks it to update the display. And when there's active, meaning we've been disconnected and now we're reconnected, so if the connection drops and then comes back, it will then also re-update the view, so if anything new's come in. Here it is. So I have a shopping list app. And we need to remember to buy things from the shop, right? This is all cool. And it's syncing up to CouchDB. So if we look in the shopping database on CouchDB, it's here. If stuff, include the docs. There's the milk, there's the bread, right? So it's PouchDB. It replicates up to CouchDB. Let's have two of these. So I put this here. And I'm using another browser so that it gets its own PouchDB, which is already connected and replicated. So I can add things here, and it will appear in both places. This is as if it was two different devices or two different things. Each one has their own local PouchDB. Now, imagine something's gone wrong with your internet connection. Unlikely, I know, but it could happen. So what we're going to do is we're just going to fake this by exiting CouchDB. So I now can't connect to that server that we're syncing through. So when I start adding things in both places, what else do I need to buy? Let's get more interesting. I can buy cake and wine. They're not syncing because there's no way for them to sync. I need chocolate. Good. Great. So we're working independently. The apps still function perfectly well, even though they can't connect to the server. Now, let's say that I come out of the tunnel on the train and everything reconnects, but I've made changes in two places. this is where we see Apache CouchDB will immediately open a tab, which we don't want. And if you watch, there we go. Chrome's always first. Doesn't usually make me wait this long. It will sync. It will. I'm prepared to just keep talking. It will sync. So normally it does make me wait, but this is like a whole new level of wait. So what's happening here is you can make changes in both places. It's new records, right? So it's a really safe demo. So the new records just arrive as a new record in the other database that they came from. So by using this, we're starting to see these offline first progressive web apps features landing all over the place. CouchDB is very approachable as a back-end database. It's very easy to work with. Come on. I could refresh it, but I shouldn't have to. Live demos was never a good plan. So you get this offline first idea. And we're using this in a bunch of different settings. Perhaps we go to Africa and we use a device somewhere which doesn't have connection to collect data of some kind, and we bring it back to civilization and get it connected, and all that data can be uploaded or downloaded. Maybe it's... I feel offended. You feel offended? Why? I'm from Africa. You're from Africa? But there, okay, well, there are some places that don't have connection. What I was going to say next was, like, we imagine this as being a third world problem, right? Africa doesn't have connection. This is the problem which solves it. You're wrong, because I live in the West, civilization as I just called it, but I regularly lose internet connection. I live in the north of England. We have hills and tunnels on the train line. Sometimes I use underground metro systems. Sometimes the mobile phone masts stop working by my house. I still need my apps to work. This style of building stuff really isn't just about places that you expect to be offline. It's almost more about places where you expect to be online. You're planning to be online. By building like this, your app always seems online to the user, and it's as online as it can be. It doesn't interrupt the person using it, and then it syncs when it can. I'm really disappointed in my demo. Come on. I just refresh it, yeah. Just made the script fire again. I'm not sure what I did there. Cool, so I have some resources here for you, and I'll ask you if you have any questions in a moment. I have some resources here for you. I blog about this stuff. The CouchDB homepage is here, as is the PouchDB one. If what I've said here about offline first is interesting to you, go to offlinefirst.org. There are other ways of implementing this type of thing, but I think the CouchDB PouchDB is the top choice at the moment. So this was just a little taster, and you can find out more about it. They're open source projects, so if you like it, please tweet at them, because I just think it's brilliant that someone built this. My joined in link is at the top. I inflict technical talks on people a lot. So if you want to save the next audience from something you really didn't like, or encourage me to do something that did work for you, I'd appreciate some feedback. Who has questions? Yeah?
My main question is security. I mean, what stops people from updating records they shouldn't have access to?
Okay, CouchDB access control is on a per database level. This is a really good question. I need a longer talk slot. Okay, so CouchDB access control is on a per database level. So what you're going to do is every user is going to log in and have their own PouchDB, and which will sync to their own CouchDB. So on your server, you will have this honeycomb of tiny CouchDBs that are replicating to places, because the access control is per database. So you're going to create a database per person or group of people that need access to a thing. The tooling is getting better, so there's new kind of ways for small databases to replicate to one central master database. It's on the roadmap, but you can't do it today. So that's a good question. Yeah, it's per database. Cool. Yeah?
Very large data sets, if you pull them completely into your browser, it will probably not work.
It will probably not work, yeah. So what I see often is one PouchDB replication, which is like just enough to load the page, and then some additional data. Try not to download too much, but I have seen some where, for example, the product catalog gets downloaded so that you can browse offline, and then when you're connected, you can put things in the shopping basket. So there's a middle ground, and the limitation is probably how much storage you have in your browser. Okay, awesome. Well, thank you so much for joining me in the Hangover slot. I'm here all day, so if you have questions, just stop. Thank you very much.